Okay, density. Anybody studied density before? What does density measure? Okay, let's think about this. Which is heavier, a piece of wood or a piece of steel? Okay, you automatically want to say steel, right? But a redwood tree is heavier than a paperclip. Oh, that's what it matters how big the pieces are, right? But you instinctively said that steel was heavier. And that's because if they were the same size, the steel would be heavier, right? That's density. Density is comparing the same size, how heavy it is for its size. Okay, so that's what density is. So it's got weight in it, like how heavy it is, but that concept of that you said, that steel is a heavier stuff, really it's a more dense stuff. Okay? And the place we use density most often, that they talk about density most often is in floating. Because things that are dense don't float. Because they're heavier than the amount of water they're taking the place of. So they're heavier, so they push down more than the water, so they push the water out of the way. Okay? More dense sinks, less dense floats. So wood is less dense, it floats. Steel is more dense, it sinks. But, okay. So notice, I don't have to talk about how big the piece of wood is that's going to float. I don't have to talk about how big the piece of steel is that's going to sink. All I have to say is that a piece of wood is always going to float. A piece of steel is always going to sink. So depends on what it's made of, not how much there is. So a little piece of wood and a redwood tree, same density, as long as they're the same kind of wood. There are some woods that are dense enough to sink. You get some of the tropical hardwoods, teak. There's a wood called ironwood. It's really dense. Okay, so what you have to do is you have to get rid of size as a factor. And scientists do that by dividing by it. And size is volume, how much space it takes up. So we calculate it by taking the mass and dividing it by the volume. Mass over volume. So there's the equation. Density equals mass over volume. D equals m over v. And the equation being written this way explains why density doesn't depend on size. Okay? Because if I doubled the size of my sample, so instead of picking up a little brick, I pick up a big brick. Okay? Let's say that means instead of picking up a light brick, I picked up a heavy brick. If I had twice the mass, I'd also have to have twice the volume. So twice the size would be twice the mass. And if you put those numbers in your equation, if the first one was x over y, the second one it doesn't even matter what it is. The second one would be 2x over 2y. And the 2's would cancel out because it'd be twice as big. So the math shows you, y doesn't depend on size. Only what it's made up of. Make sense? Okay. There's lots of places to use density. We're going to want to use it with gases because using the density of a gas will tell us something about that gas. Okay, so there's our equation. So, talk about wood. Let's do a sample problem piece of wood has a mass of 25 grams and a volume of 25 milliliters. What is its density? What is its density? So density is mass over volume. The mass is 25 grams. The volume is 35 milliliters. You divide that, 25 divided by 35, and you get 0.71. And the units are grams over milliliters because they don't cancel out. Since they don't cancel out, we leave them right where they're at. And density will always have two units because you will always divide a mass by a volume and the units will never cancel out. So you always have a mass on top and a volume on the bottom of your units. So grams per milliliter. Okay. So that's got a density of 0.71. Now to chemists, what this tells them is that we know the density of water, okay? Because if density is mass over volume, for H2O, we said the definition of 1 gram was the mass of 1 milliliter of water at 4 degrees Celsius. That's what we said the definition of a gram is. 1 gram per milliliter. So anything with a density above 1 gram per milliliter sinks. Anything with a density below it floats. This wood floats because 0.71 is less than 1. See how we can use this? Talk about sinking and floating. That's a physical thing you can see about density. But we're not talking about pieces of wood this chapter. Try the density of a gas. So for a gas, we are not going to measure the weight of milliliters of gas because it's way too small. So for a gas, we're going to need a bigger sample size. If we want grams of weight, we're going to need liters of gas. And the reason why we're studying this is it's going to give us a way to figure out the molar mass of a gas. We can determine the density of any gas at STP if we know its formula. Here's the logic. If I have the same volume of gas, yesterday we said they had the same number of pieces. So a liter of oxygen and a liter of helium both have the same number of pieces. But the helium pieces are lighter than the oxygen pieces. So for the same volume, the oxygen's heavier because the pieces are heavier. And so that's going to tell me how heavy the pieces are. How much heavier they are than helium by how much more dense they are. Okay, so what do I need if I want to find the density of a gas? I need mass and volume. That's how you find density. I need those two numbers. So I need some place where I know both the mass and the volume. And it doesn't matter how much I pick. Okay? So in order to find the density, I need the mass and the volume, and I can pick any amount I want. I'm going to pick a number that makes my life easy. I'm going to pick 1 mole. Because if it's 1 mole of a gas at STP, well, first of all, it's 1 mole. 1 mole is the molar mass. Those numbers you add up off the periodic table. So if I assume 1 mole, I get the mass by just adding up the numbers on the periodic table. And I get the volume, the liters, because it's 1 mole. And how much space does 1 mole take up at STP? 22.4 liters. So as long as I know the formula, I can always figure out the molar mass, and it's always going to be 22.4 liters. So just from the formula, I can get the density. So we need a mass over a volume. The mass is going to be the molar mass. The volume is going to be, we called it the other day, the molar volume. Molar mass over molar volume gets the density. So find the density of CO2 at STP. Density equals mass over volume. We're going to assume 1 mole. So I've got 1 carbon and 2 oxygens. 1 carbon is 12.01 grams. 2 oxygen is 32.00 grams, 2 times 16. So CO2 weighs 44.01 grams. So that's the mass I'm going to use. If I had a mass of this, it would weigh 44.0. If I had a mole of this, it would weigh 44.01 grams. That's 32.1. 00. 16.00 times 16.00. Okay. And the volume, well, that's 1 mole, so 1 mole of gas would be 22.4 liters. So 44.01 divided by 22.4 equals 1.96 grams per liter. Well, it's liters now. Now, so what we'd have to compare it to is air. Okay, that's what we'd have to compare it to. We want to see if this balloon is going to float in air, right? Because it's liters now. It would definitely float in water because it's way lighter than water. Okay, but will it float in air? Well, air is O2 and N2, and it's mostly N2. And O2 is 32 grams a mole, and N2 is 28.02. So chemists treat air as 29 grams for 1 mole. Okay, 29 grams for 1 mole. Okay, so 29 grams for 1 mole compared to 22.4 liters, because that's 1 mole. The density of air is 29 divided by 22.4, 1.3 grams per liter. So air is 1.3 grams per liter. CO2 is 1.96 grams per liter. It's the average of 32 and 28 for O2 and N2. Because the air we're breathing is 80% N2, 20% O2. So it's going to be closer to N2 than to O2. Actually, if you take 0.8 times 28 plus 0.2 times 32, you'll get 29. The math actually works. No, I just want to give you a sense that air is 1.3 grams per liter. This is 1.96 grams per liter. It won't float. In fact, it'll sink. CO2 sinks in air, which actually can cause a problem because if you don't have good air circulation and you got a fire making CO2, that CO2 is going to sink down. And CO2 will actually fill the bottom, so you run out of air at the bottom because you got too much CO2. CO2 sinks. Okay. So pretty easy to find density. Okay. All right, I want to do one more, and I want to do SF6, sulfur hexafluoride. Find the density of sulfur hexafluoride. So I start with the idea that density is mass over volume. The mass I want is 1s and 6 f's. So 1s is 32.06. 6 f's is 6 times 19, which is 6 times 20 minus 6. So 6 times 20 is 120, 114. $146.06 grams. Divided by what volume are going to be? 22.4, because they're both, the reason why, because they're both 1 mole. Okay. 146.06 divided by 22.4 is 6.52 grams over liters, because they don't cancel out. So, is this going to float or sink? It's going to sink. This is much more dense than air. It's like 5 times as dense as air. So let me show you an impact of that. Okay. Drag is such a drag. Okay, so they have filled this aquarium with SF6. SF6 is more dense, so it's going to sink down and it's going to fill up that aquarium. Okay? So, it's in German, so you can translate for us. Yeah. You can't, I turned the sound off, but it is in German. Okay.
Oh, whoa, hold on.
Okay, turn the sound
Hey,
off.
that's more. Hey, bro, there's nothing in there.
Oh, yeah, there is. How the heck did that happen?
What? Hey, I'll trick somebody.
No, it's not trick. Okay. We said it was more dense than air, right? The sound is on my other computer. I got to stop. So, hey, why does it float? Okay. Well, we said steel was heavier than water, right? I know, but get the idea. Okay, steel is heavier than water. Steel sinks. What are ships made of? No, they're made of steel. How come they don't sink? Because it's hollow on the inside. It's not the steel that floats, it's the air, the trapped air. If you drill a hole in the side of the boat and get the air out of there, the boat sinks. Okay? So the reason why it floats is because it's trapped air. Yeah. It would not float, it would sink. That little boat of aluminum foil is full of air. That air is less dense than the SF6. So it floats.
And then
They would put that
Okay,
SF6
six.
in there.
So it's just like they were picking up a cup of water. It's more dense. It pours.
Oh, gassy.
It's just like pouring water. Okay. Okay. A couple reasons I'm not going to show that to you. One, SF6 is expensive, and B, it's a 60 times more powerful greenhouse gas than CO2. So we don't want to just release it into the atmosphere. Okay. But if you catch an old Mythbusters episode, okay, what kind of gases float? What gas do you know that floats? Helium. Why does helium float? Because helium's only 4 grams a mole, divided by 22.4.
Why would you do the whole thing? Like helium and make
That's where we're going to. What happens if you inhale helium?
Oh, your voice gets all
Voice gets really high, right? And that's because of the density. It's not doing anything to your vocal cords. It's just because helium has a different density than air. Just like if you're in the pool, things sound different in the pool. Everything sounds higher pitched in the pool. That's because it's going from lower density the air to higher density the pool. That always makes it sound high pitched. Well, the same thing's happening when you talk with helium. It's going from low density the helium to high density the air, so the pitch goes up and everything sounds high pitched. It's not doing anything to your vocal cords. It's technically changing the speed of sound. Okay? It's safe to breathe the helium. There's one little problem is you got to remember to breathe air in between. Okay, the helium's not poisonous, just don't forget to breathe air in between. Don't try to do it continuously because you'll fall down on the ground. And you won't feel short of breath because you're not piling up carbon dioxide. You're just not breathing oxygen. So carbon dioxide is what makes you feel like you need to breathe. So that won't build up. You'll be breathing just fine. You'll just fall over because no oxygen is getting to your brain.
And like when you inhale helium,
Yeah.
and like after really quick, like the high pitch is gone.
Because all the helium's left your lungs. Only while the helium is flowing through your air pipe does it do that. So what about SF6?
Well, would it make your voice more
Makes your voice deep. Makes everybody sound like James Earl Jones.
I'm gonna do that.
It's again, and also it's not poisonous. It's just a nasty greenhouse gas. So we don't want to release it to the atmosphere. Okay. All right. So let's do this. Let's try this. Try this. Which of these gases would have the greatest density? Okay. You should be able to do this without doing any math. You can think about the numbers, but not actually have to do the math. Okay. What would make a gas more dense? The mass. So the mass of 1 mole. So all you have to do is look, say, how heavy is 1 mole of O2? 16 times 2, 32. How heavy is 1 mole of N2? 2 times 14, 28. Cl2, 2 times 35.45, 70.9. F2, 2 times 19, 38. Argon, 39. So it's got to be the chlorine because the chlorine's the heaviest of all those molecules. That make sense? Okay. Now, if the formula can give us the density, then the density will tell us something about the formula. The density will tell us the molar mass. If I could just look at the molar masses and see which one was more dense, that means I should be able to look at which one's dense and figure out what the molar mass is. Math is reversible. Okay? You learn a function, then you learn the inverse of that function. Okay. So I can work it backwards. Given the density, I can find out the molar mass. Because it doesn't matter how big my sample is. And I can pick any amount. So I'm going to pick 1 mole again. Because then I will know the density and I'll know the volume. since the equation only has 3 pieces, and I know 2 of them, I can find the third. I just have to rearrange my equation to solve for m, which is pretty easy to do. If you've got d equals m over v, how do you get the m by itself? Multiply both sides by v, right? So that's what we're going to do. M equals d times v. And because we're using 22.4, the mass I'm going to get is for 1 mole. Because the volume is 1 mole. If I had 1 mole of gas, this is how much it would weigh. Okay, so the math is pretty simple, and it makes the units work out too. So, what is the molar mass of a gas with a density of 1.964 grams per liter? Okay, so I've got 1.964 grams per liter is my density. And density is mass over volume, so I'm going to do mass is density times volume. The density was 1.964 grams per liter times a volume of 22.4 liters. Okay. 1.96 times 22.4 equals 44.0 or 43.9, which is, take off your seat. No, the bell does not dismiss you. I've got a point to make here. Okay, 43.9, no, 44.0, which is grams, because the liters cancel out, which shouldn't surprise you. Because a second ago we said CO2 had a mass of 44.01 grams, so it had a density of 1.96. If it has a density of 1.96, it should weigh 44. That make sense? Yep. There you go. Have a good one. Practice is in the book. Take care.